Hello, Luke. Welcome to lesson 31. So today we're going to be talking about equations with parentheses. All right? Just kind of adding to our knowledge base of equations. All right. So before we get started on that, we're going to talk a little bit about parentheses. And I know that you know what parentheses are and how they're used, but I want to make sure that we know when an appropriate time would be to drop parentheses in an expression. So, for example, if I have, negative 6 plus parenthesis 3 plus 2 plus 1, or if I have maybe a negative 6 times parenthesis 3 plus 2 plus 1, or maybe I have negative 6 minus parenthesis 3 plus 2 plus 1. All right. The goal here is just to clarify when we're permitted to drop the parentheses without worrying about that wrecking our value for this expression or changing the value for our expression. So in the first one, negative 6 plus this set of parentheses, it's actually true in this case that we can actually drop the parentheses here. We can actually get rid of these right away. Okay, and it just becomes a negative 6 plus 3 plus 2 plus 1. Okay, in the second one, we can't yet. And in this third one, we can kind of. There's just one small step that we need to do before we can drop these parentheses. All right, so today we're just going to kind of discuss this a little bit and make sure that we're very clear on when we can drop parentheses and when we can't. All right, so I guess let's we'll come back to these in a second maybe, but let's just start by talking about a generic set of parentheses. So if I have some set of parentheses and there's something in here, okay, I won't write it, but there's something inside this set of parentheses. There might be multiplication, there might be addition, subtraction, division, who knows. There's something though inside this set of parentheses. Now if we think about it on the outside of this set, there's only a couple of options or a couple of things that might happen to us on the outside of this set of parentheses. We might have, maybe an invisible or visible multiplication sign here, and maybe we're multiplying that whole set of parentheses by a 3. Okay, that might be one possibility here. Okay, another possibility, maybe we've got our set of parentheses here again, but in this case, we have a plus sign outside the set of parentheses. Okay, and maybe there's something out over here. Maybe there's a 2 plus and then the set of parentheses. All right, that'd be another possibility. A third possibility might be that we have a set of parentheses and then outside of this set we have a negative sign. So maybe we have a 2 perhaps, or maybe not even a 2. I mean, we might just have nothing out here. It might be just a negative and then set of parentheses. Okay, so when you think about it, those are pretty much the three options here. We could talk about division, but we won't in this case. It doesn't really apply that much. When division is more of just another way of multiplying. So we won't worry about division, but we will look at the negative and the plus and the multiplication. All right, we've got 3 different scenarios that we'll be dealing with here. Okay, so the first scenario, 3 times a set of parentheses. Well, I cannot just drop this set of parentheses. Okay, when there's multiplication on the outside, this is a rule that you just need to remember. You can never just drop the parentheses without doing anything. Okay, you have to do something in order to get rid of those parentheses. All right, if it's multiplication. If it's addition, if it's a positive set of parentheses, then no matter what, it doesn't matter what's going on inside these parentheses. It is totally legal and permissible to just drop these parentheses when you have a plus sign to the outside of them. All right. And by that, keep in mind, I guess I should say that what we've written to the left of these set of parentheses, it may also be that there's something to the right. So if there were, for example, multiplication going on over here, well, we have a set of parentheses, and right after it, we have multiplication. This would fall under the first scenario. All right, it's just written out to the right here instead of to the left. So because it's multiplication, that would tell us that no, we can't just drop the parentheses. We have to do something first. Okay, so keep in mind that I'm only kind of showing this on one side, but maybe there's something else going on the other side, and you'd need to take that into account as well. But for right now, we'll just say there's nothing on that side. And if we just have a positive sign here, then we can just drop this set of parentheses. It's not really necessary. It's not needed. And that would fall under this first category over here. So if I look at that, maybe I'll just move some of this out of the way, get these out of the way, and we'll look at just this first one. That falls under this second category. It falls under this one, right? We have an addition sign outside the set of parentheses, okay? And so because we have that addition sign, the rule is you can drop it. And maybe I'll just put that over here. If it's this, then we can drop the parentheses. All right, so if it's a positive sign on both sides, or if it's just on one side and nothing on the other, then we can drop the parentheses. And that's what we have going on over here. The plus sign is to the outside. We can drop those parentheses, and it's not going to change anything. Well, actually, I've already written it again, so we'll just take a look at these two. If I were to keep the parentheses here, let's just for the sake of the argument, let's just say I keep the parentheses. All right, and we know that by keeping the parentheses, that means we need to do the parentheses first. So if we do them first, we have 3 plus 2 is 5, plus 1 is 6, right? That's what would be inside that set of parentheses. And then to the outside of that, we still have our negative 6 plus 6. So a negative 6 plus 6, well, that's going to equal 0, right? Now over here, I dropped the parentheses, and I just rewrote the problem exactly the same without the parentheses. So did that change anything? Well, let's just simplify this. Negative 6 plus a 3 is going to be a negative 3. A negative 3 plus a 2 will be a negative 1. Negative 1 plus a positive 1 is a 0. So lo and behold, it didn't affect anything by dropping those parentheses. It didn't change the outcome of this expression. Okay, and that just kind of confirms a little bit of what we've been saying all along, and that is if it's positive on the outside, we can drop the parentheses, and we don't have to worry about anything going afoul as we go down through our work. All right, now let's take a look at the next scenario here. So if I've got this next one, and we'll just pull this one up into place here. This one, what does this fall under? Which one of these three scenarios does this particular problem fall under? And if we look at it, we'll note that it actually falls under the first scenario. So this one falls under the first scenario, all right? And that is the multiplication. We have hidden or invisible multiplication going on here, so we have multiplication outside the parentheses. That falls under this scenario. So what we have to do here, now you might argue that, oh, well, Jim, I can just add up these parentheses. That's not that hard. I can actually work this out, and 3 plus 2 plus 1 is 6, and do my parentheses first. But bear in mind, we're taking easier problems, and down the road, this may not be workable. Maybe this is x plus y plus z in here. And maybe, you know what, just for the sake of the argument, so it's clear, let's put that in there. Let's just do that. Let's make this, negative 6 times an x plus y plus z. Okay, now I think it's pretty obvious that we can't do the parentheses first. They're variables and we don't know what they represent. So therefore, we can't do the parentheses first. So how do we get rid of the parentheses? And we can get rid of them if we first use our distributive property rule. Okay, so if we use our distributive property, we remember that we can take this negative 6, multiply it by the x, and then multiply it by a positive y, and then multiply it by a positive z, right? Distributing it through, all right? So let's do that right now. So if we have a negative 6 times an x, that's going to give us a negative 6x. A negative 6 times a positive y, well, that's going to be a negative 6y. And a negative 6 times a positive z, well, that's going to be a negative 6z, right? At this point, we've lost the parentheses. They're gone, all right? By doing the distributive property, we lose the parentheses. Does that make sense? So if you have multiplication, remember that when you distribute it through, you're also losing the parentheses, which is very handy later on, okay? So can you get rid of the parentheses when there's multiplication? Yes, But first, and maybe we'll write this over here. First, use distributive property. Okay, so yes, you can, but, and there's a but there, we have to first use distributive property. All right, then we're done with the parentheses. Okay, the last scenario here. Let's take that one. So if I've got a problem that looks like this, and we'll pull this one up here, -6 minus parenthesis 3 plus 2 plus 1. And you know what? Again, we're going to make this an x plus y plus z. Oops. Go back to my black. All right, x plus y plus z. Okay? All right, so now how would we get rid of the parentheses here? Now, the first thing we look at is we see that there's a minus sign here. It's a negative. So it doesn't fall under the second category because that would be if it's a positive. So we can't just drop them because it's not a positive sign. It's a negative sign, which is our last category over here. Okay, so if it's a negative sign, what do we do? Well, in a sense, we're going to be using the distributive property again. But it's in such a simple way that there are faster ways to think of this. So, but just so it kind of makes sense to you, if I take this negative parenthesis x plus y plus z, I can think of this as having an invisible 1 right here. Right? He's invisible. Invisible 1, and he's being multiplied by this whole set of parentheses. It's actually saying a -1 times this set of parentheses. Okay, you might have even decided that when you're looking over here. This one you could also say there's an invisible 1 here that you're multiplying by the set of parentheses. But notice up here that invisible 1 doesn't change anything. If I take a positive 1 and multiply it by anything, it's not going to change it. A positive 1 times, a 3 is a 3. A positive 1 times a 2 is a 2. A positive 1 times a negative number is still that negative number. So the positive 1, when you're multiplying it by things, will never change anything at all. It just remains completely the same. So that's why we could just drop these without doing anything. Because all we were, theoretically, we were actually multiplying that positive 1 through, but that didn't change anything. So we can just drop those parentheses without even thinking about it. But down here, we have a -1 times everything in the set of parentheses. And now a negative 1, that will change these values over here. And they'll change because of this negative sign. Because a negative times a positive is going to be a negative, right? Remember, the negative is stronger. So a negative times a positive is going to give you a negative. So a nice way to think about this is if we have this negative sign outside of our set of parentheses, we can drop the parentheses if and only if we change all the signs in the parentheses. We have to change all the signs in the parentheses to the opposite sign. Okay, so this would become then, maybe we'll do it a different color, -6, we just pulled that right down, and then this minus set of parentheses, well, we can lose the parentheses, but we have to change all the signs for all these terms inside. So this is a positive x right here, right? We're going to change that into a negative x. And notice I lost my parenthesis. I also did not write this negative sign again because I'm kind of using him to change all these, and I use the signs that I get with these terms. I kind of eliminate this negative here as well. So this becomes a negative x, and then this positive y becomes a negative y. This positive z becomes a negative z. Okay, now my parentheses are gone. All right, so that is how I can eliminate the parentheses if it's a negative sign. All right, so just to recap and make sure you've got these straight in your head. And actually, let's put that over here. We can drop the parentheses. First, we must, though, change all the signs for the terms inside the parentheses. Okay. All right. So those are kind of the three things. If it's so as a recap here, let's just briefly run through them. If it's multiplication, well, then we have to use the distributive property. We need to distribute this through every term inside the parentheses. Okay. If it's addition, no problem. We can just drop these and be done with it. We just drop those parentheses and we're done. That's when life is wonderful, when we have the addition sign outside the parentheses. All right. Negative, not so bad. All we have to remember is that everything inside the set of parentheses, its sign will change to the opposite sign. So if it's a positive, it'll change to a negative. If it's a negative, it'll change to a positive. All right. So once again, maybe just to illustrate that one, I'm going to give you another problem like that. What happens if I have just a negative? Well, we'll go a different color. Negative y plus z minus 2y. Well, we'll keep the variables different. Minus 2w plus ab. Okay. So if I want to drop these parentheses, we notice that we have a negative sign out here. So we can drop the parentheses if we switch all of the signs inside the set of parentheses. So this negative y, well, that's going to become a positive y. This positive z will become a negative z. Negative 2w, positive 2w, plus ab, minus ab. All right, and then that would be equivalent. This would be a simplification of this first expression. We've removed the parentheses, but because this is a negative, we've, in a sense, distributed that negative through each term, okay? And a negative times a negative y is a positive y. A negative times a positive z is a negative z. A negative times a negative 2w is a positive 2w. And a negative times a positive ab is a negative ab, all right? So that's all we're doing. We're distributing that negative through, but we can think of that as simply switching the signs on everything inside the parentheses. All right, so hopefully that makes sense. Let's move on now and start using what we've learned there and solve some equations. So I'm going to pull a couple of these right out of our book. If I have 2 times 3 minus b equals b minus 5. b minus 5. Okay, so when solving equations, I'm going to give you a list of steps here. And bing, there it is. So let's take a look at this. And let's see, where should I put this? If I put it out here, maybe I can move some things out of the way here. We'll put the equation over here. Okay, so these are our steps for solving an equation. Now notice I say an equation with x. That's just to kind of clarify some of these statements here, but it really is an equation for anything. Whoops. So if this x were in fact a y, or in this case like we have over here, it's a b. If we're solving for b, we're going to be using these same steps. It's just all the x's inside these steps would be b's. And if we were solving for a y, then all these x's would be y's. So the steps are the same. All right. So the first step when solving equations is always to eliminate the parentheses on both sides of the equation. Now that's if they're there. All right. So we should always look first and say, okay, do we have any parentheses? And if we do, we need to eliminate those parentheses first. And that goes back to what we were just doing a moment ago. So looking at this expression, this equation, we'll look at the left-hand side and recognize that we have a set of parentheses here. So we need to take the appropriate action to eliminate these parentheses. And as we discussed previously, we see that this is multiplication. So we are then going to use the distributive property to multiply this through all the terms to get rid of the parentheses, right? So if I have 2 times 3, that's going to give me 6. And then a 2 times a negative b is going to give me a negative 2b. And then, of course, I still have the rest of my equation equals b minus 5. All right? That's our first step. Done. Okay, now the second step, simplify both sides of the equation. Well, in this case, we look at the left-hand side, and can we do anything here? Is there anything to simplify? Any like terms that we could combine or that kind of thing? In this case, no, there's nothing on the left, and actually there's nothing on the right either. There's nothing that we can do on that side. So, boom, step 2 is done. We've done what we could. All right, number 3, get all of the x's on one side of the equation. Well, in this case, it's b's, so we're actually getting all the b's on one side of the equation. And here we get to decide what side of the equation do we want to put our b's on. Now, again, as I've always said before, I'm not a fan of having negative variables, so I'm going to take the negative one here and add a positive 2b to it. Add a positive 2b on this side, right? What you do to one side, you have to do to the other. And then I can eliminate these two, and I'm left with a 6. And then over here, I've got a 2b and a 1b, which is going to give me a 3b total minus 5. Okay? So now I've got my b's on one side. It's on my right side in this case. So we've done step 3. Step 4, get the x term by itself. So in this case, it's the b. Get the b term by itself. So what's the b term? Well, this is the b term. Right? So we want to get that guy all by itself. And so to do that, we need to get rid of all these other things going on over here. So we need to get rid of this negative 5. And to do that, we're going to add 5. That'll eliminate the negative 5. But that means we have to add it over here. So we end up with an 11 equals 3b because these are going to eliminate, right? So now we've done that step as well. Step number 4 is done. Now we have to get the x by itself. So we started by getting the x term, which is the full 3b. Now I just want to get the x all by itself, which in this case is the b. Get the b all by itself. So to do that, we need to get rid of the 3, which means we're going to divide both sides by 3, right? And we end up with these 3's crossing out, and we have a b left over equals 11 thirds. And I just wrote it the opposite way because that way we have the b out in front. So b equals 11 thirds. That would be my solution to this problem. All right. So it's the same thing that you've been doing for quite a while. Really, the only difference is the additional step at the beginning, which is to eliminate the parentheses. Okay. That's really the crux of the whole lesson today, is getting rid of those parentheses. All right. So let's try another. You know what? We're going to just throw this on here again so we've got it handy. And actually, while I'm writing this equation out, what I want you to do is take out, I'm hoping you have maybe a math notebook that you can use for your study notes, right? And in that math notebook, I want you to go ahead and write out these steps. You know, and if you don't get them written out here by the time I write my next problem, that's fine. At the end of the lesson, go back though and just write these steps out on your study sheet so that you can study them for homework, so that you can really get these steps memorized. All right, so they become kind of second nature to you. All right, so let's move on here where I'm going to write out another problem here. Okay, so let's give this a shot. So again, the first step, eliminate parentheses. And again, on the left side, we do have a set of parentheses and it's multiplication in front of the parentheses. So what are we going to do? We're going to multiply that through. So we take the 3 times the 1, that gives us a 3. Take the 3 times the positive 2x, so that gives us a positive 6x. Parentheses are gone. So now we just need to tack on anything else that's left over. In this case, we have still a plus 7 equals. Now over here, we also have a set of parentheses. And again, it's being multiplied. So we're going to do the same thing. Now, remember to keep the sign with the coefficient. So we have a negative 4 times an x, which is going to give us a negative 4x. And then we have a negative 4 times the positive 2, which is going to give me a negative 8, right? And again, notice parentheses are gone. So step 1, check, done. Now we can simplify both sides of the equation. So over here, we do in fact have some like terms. We've got a 3 and we have a 7, right? So we can combine those. I'm going to maybe just write the 6x first. And then I have a 3 plus 7. Well, that's going to give me a 10. So I have a 6x plus 10. on the left side. And on the right side, do I have any like terms? No, I don't. So I'm just going to rewrite it. Minus 4x minus 8. All right? So there, we've simplified. Now we have to get all the x's on one side. Okay, well, to do that, let's take this negative 4x, and we're going to add the 4x. And then we'll have to add him over here as well, which is going to give me a 10x plus 10 equals, these eliminate, minus 8. Okay? There we go. X's are all on one side. Now we have to get the x term by itself. And again, the x term is this guy, the 10x. So to get it by itself, we'll have to subtract 10 on this side, subtract 10 on this side. These will cross out. We end up with a 10x equals negative 8 plus a negative 10. Well, that's going to give me a negative 18, right? That step is done. Now we have to get the x all by itself. So how do we do that? We have to divide it by 10. And we end up with x equaling a negative 18 over 10. I could reduce that, though, and make that a negative, what, 9/5 if I divide both of them by 2, right? So I end up with x equals a negative 9/5. All right? Let's try another one here. And this one, I want you to try to do it on a piece of paper first, and then we'll do it together. So this one is going to be 15. We're going to start using some larger numbers here. All right, so give that one a try, and then we'll do it together. All right, so this one again, it's clear. It's just multiplication again. Nothing has really changed here. So 15 times 4. Well, might have to do that off to the side. Otherwise, if you recognize that 15 times 2 is 30, well then by 4 it's going to be 60. 60 minus 15 times 5. Oh, is what? 75. 75x equals 16 times 4 is 64. Minus, let's see, 16, 30, 96. Hopefully I did that right. Plus 10, right? Okay, let's do our next step here. Let's simplify both sides. There's nothing to do on this side. On this side, and actually I'll just rewrite this then, 60 minus 75x. On this side, we do have a 64 and a 10 that we could combine. So that's going to make 74 minus 96x. And now here, I think I'll add the 96x to try to get the x's by itself. So we'll add 96x to both sides. These will cross out. We're left with 74. Now a 96x and then a negative 75x is going to be what? A 21x, I believe. And that's a positive 21x. And then we have a 60. Now we can subtract the 60 to get the x term all by itself. 60 goes away. We end up with 21x equals 14, right? And then we can divide both sides by 21, and we end up with x is equal to 14 21ths, right? Now I could actually reduce that. I could recognize 7 goes into both of those. So 7 go into 14 twice, into 21 3 times. So we end up with x equaling 2/3. All right. Make sense? Great. Let's try another one. And I'm just going to write it over here. Let's go. Okay, there you go. Give it a whirl. All right, so let's see how you did on this one. This one, we notice we don't actually have multiplication for the parentheses. So this would fall under those other categories we talked at the beginning of the lesson. So the first one, we have a negative outside of the parentheses. So remember, that means to switch all the signs on the inside. So we have a 12 that I'm just bringing straight down from up above. And then this negative is going to change this 2x from a positive 2x to a negative 2x. And it's going to change this positive 5 to a negative 5. All right? It's as simple as that. We have our equal sign. We have a minus 2. Now here on this side, we have a plus a set of parentheses. Remember what I said earlier. If there's a plus, we can just drop the parentheses. So this x is a positive x. So we're going to write him as a positive x. And then the minus 3. All right. Very good. Now, if this x were a negative x, keep in mind you would have want to have written this as a negative x. All right. If it's a positive x, as it is here, it's invisible. We need to write it as a positive x. All right. Very good. So now we can combine like terms. We have a 12 and a negative 5, and a 12 and a negative 5. Well, that's going to give us a 7, right? And we have minus 2x equals. Now here I have a negative 2 and I have a negative 3. I can combine those to give me a negative 5 with my leftovers here plus x. Then let's get the x's all on one side. Yeah, just for the fun of it, let's make ourselves have a negative x here. So if we have a negative x over here and a negative x over here, we're going to end up on this side with a 7. And then a minus 2x and a minus 1x is going to give me a minus 3x, right? Equals, these cross out. We have our negative 5. Now I can subtract this 7 from both sides. That will eliminate. And we're left with a negative 3x equals negative 12. Now I can divide. And if I divide the negative 3x by negative 3, same thing over here. I end up with an x. Now, a negative 12 divided by a negative 3, negative divided by a negative is a positive. So I know my answer is going to be positive. I also know that 12 divided by 3 is 4. So it's going to be a positive 4. So x is equal to 4, right? Very good. So again, this one had a nice combination of parentheses. We had the negative one here and we had the positive one here. And remember the negative one, we just switched the signs on the inside of the parentheses. And the positive, we just dropped the parentheses. Life is wonderful if it's a positive. Okay? Very good. So that, I think, is about where we're going to stop today. Should be pretty straightforward. Actually, you know what? Let's do one more. One more that maybe just is a shade more complicated, just to make sure that you've got a handle on this. So let's do a negative 4y minus 17 plus a negative y. Okay. Let's try this one. We got all kinds of parentheses going on here. So first, let's get rid of the parentheses. So we're just taking the left-hand side here and kind of attacking each set of parentheses one at a time. So we have this first set. It has a negative sign out in front. So what do? You got it. Let's change these inside terms to a negative, or the opposite sign. So we have a positive 4y, negative 4y. Negative 17 becomes a positive 17. All right. Then we have our plus sign. And since this is a plus outside of a parenthesis, we don't need to do anything. We can just drop the parentheses. And you might notice that if I drop them, I end up with a plus minus y, right? Which isn't the best way to write that. A plus minus, well, that's just going to be a minus, right? So we have a minus y equals. Here we don't have anything. We just have, you might say, we have an invisible plus sign out here, okay? So if that's the case, then we can just drop the parentheses and end up with a 2y minus 1. Now, don't get confused on this one. This one's kind of actually a good one because there is a negative sign on this other side. Okay. And remember earlier, way at the beginning, maybe I'll switch over to that. I talked about how, you might have a multiplication sign, on this side. And if you have a multiplication sign on this side, you have to watch out because that's being distributed through, right? If it's a negative sign out here, don't actually worry about it because that negative is actually being associated with the next term in the problem. This negative is saying that this term is a negative, okay? This term is the negative. This negative is not actually being applied to the set of parentheses before it, Okay, so the only thing that can throw this off is if there's multiplication on the other side. If there's positive or negative signs, don't worry about them because they're being associated with the next term. All right, so hopefully that makes some sense to you. So we have our 2y minus 1. Now we have this minus this set of parentheses. So we're just going to change all of the signs inside there, and that's going to become a positive y. Okay, following me there? All right, so now we can do the rest of our steps, which is normal for us. We could combine like terms here. We have a negative 4y, negative 1y. It's going to be a negative 5y plus 17 equals 2y plus y. It's going to be a 3y with a leftover negative 1. All right. Now I'm going to do some of this in our head because hopefully you'll be able to eventually do this. We won't have to write as much. Here I'm going to bring my y's onto one side. So I'm going to move them over this side. So I have a negative 5y. If I move it over to the other side, it becomes a positive 5y, right? I'm just kind of doing some of this in my head. And a positive 5y and a 3y, that's going to be an 8y on this side. And a 17 is left on this side. Do you see how I did that? All I did was just kind of did this part in my head. That's all I did. I just said, oh, I'm putting a 5y here and a 5y here. That's going to eliminate. I end up with my 17. Over here, I have a 5y added to the 3y, 8y minus 1. All right? And eventually, you'll be able to do that without hardly even thinking. You're just moving this over to the other side. A negative 5y. To get it over to the other side, we have to add 5y, and that's going to combine with the 3y to give us an 8y. Okay? Same thing here. I have a negative 1 now. I want to get this 8y by itself. So if I want to add the 1 to both sides to get rid of it, on the one side, I'm just going to end up with 8y. On the other side, I'm going to have a 17 plus 1, which will be an 18, right? Now I can divide both sides by an 8. These will cross out, and I have a y is equal to 18/8, which can be reduced to 9/4, right? So my answer in this case is going to be 9/4. Okay? Excellent. We're going to stop it here. Before we do, though, make sure that you go up to this guy and write this down somewhere in your algebra study notes so that you can study them for homework. And then I will see you tomorrow.